Hello and welcome back to another IB Math speedrun, and in this speedrun we will be going through the cosine rule. So we need to remember Pythagoras' original rule, which is a squared plus b squared is equal to c squared, but this only works for right-angled triangles. And there is an extension to this rule that can make it work for actually triangles of all angles, and that's called the cosine rule. So what we do is we actually have to add a squared is plus b squared. Actually, it's normally written with the c squared first, so c squared is equal to a squared plus b squared minus 2ab cosine c. So we have, if we look at this from a triangle's perspective, it means that it can apply to any triangle where we have sides of a, b, and c, and we always label the opposite angle capital of the lowercase side. So this means that this will work for any triangle, and it's often used to find an angle when given three sides, or find given two sides and the angle between them, like a, b, and c over here. We need to find the third side, so it will work for all of those. So let's jump into some problems. So I'll do the, I don't know, I guess I'll do the even ones this time. So first we have a triangle here where we have 4, 5, and this is 95 degrees, and we need to find the remaining angles and sides. So we need to find this angle, and this side. So this side's the easiest to start off with. Let's label this side x, and then this y, and then this z. So we know x squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5 cosine 95. Actually, note that this works as well for the original 90-degree case, since we're taking this as a and this is b, and so cosine 90 is equal to 0, so this part just doesn't appear. That's why. So anyways, we have x squared is equal to 16 plus 25, which is 41, minus 40 cosine 95. And 40 cosine 95, let's just make sure we're working in degrees. So 40 cosine 95 is equal to minus 3.49. So we actually get that x squared is equal to 41 minus 3.49. So we get that x squared is equal to 44.5, and so x is equal to the square root, which is equal to around 6.67. So this is one side. Yeah. So next we want to find this angle here. Actually, I think I've labeled them wrong. Yeah, sorry, I've labeled them wrong. The actual labels are, this is y, this is x, and this is z. So we actually just solved for y. Next, let's solve for capital X. So we have capital X is equal to, well, we know this is 6.67. So we know that 4 squared, anyways, we can rearrange the formula to state that cosine x is equal to 5 squared plus 6.67 squared minus 4 squared all over 2 times 5 times 6.67. And if we evaluate this, this is equal to 25 plus 6.67 squared minus 16, all divided by 66.7. So we get that cosine is equal to 0.802, and so x is equal to inverse cosine of that, which is equal to around 36.7 degrees. And then let's do the same for the z value. So we have cosine z is equal to 4 squared plus 6.67 squared minus 5 squared over 2 times 4 times 6.67, which evaluates to 16 times 6.67 squared, plus 6.67 squared, minus 25, all over 8 times 6.67, 8, yeah. So we get 0.665 here, so we have z is equal to cosine -1 of this, which is around 48.3 degrees. Okay, on to the next question. So this is find the largest angle in triangle ABC given that A is equal to 4.5 centimeters, B is equal to 3.9 centimeters, and C is equal to 2.3 centimeters. So there's a little trick we can use. If we draw out the triangle, the largest angle should always be opposite the largest side. So if we have A, B, and C over here, then this will simply be the largest angle, capital A. So we say cosine A is equal to B squared, so 3.9 squared plus 2.3 squared minus 4.5 squared all over 2 times 3.9 times 2.3. So this is equal to, let's see, 3.9 squared plus 2.3 squared minus 4.5 squared all over 2 times 3.9 times 2.3. And we should get something like 0.014. So we have the actual angle is equal to cosine -1 of that, which is around 89.2 degrees. So this should be the correct answer. Yeah. So next question and final question we have, where are we? We have triangle ABC has sides of length 5x and 2x minus 1. Given that BAC is equal to 60, find x and calculate the two other angles. So there's a diagram to help us. So we have A, this is 60, x, 5, 2x minus 1, B, and C. Okay, well, we can calculate x. It's not too hard. Since we know this is 60 degrees, we know that 2x minus 1 squared should be equal to x squared plus 5 squared minus 2 times x times 5 cosine 60, and cosine 60 is going to be 1/2. So it's simply minus x times 5. So we have 4x squared minus 4x plus 1 is equal to x squared minus 5x plus 25. So we have 3x squared plus x minus 24 is equal to 0. And what would be the factors of this? It's definitely factorable. And this would be, let's see, 8 times 3, no, 6 times 4. Oh yeah, no, it is 8 times 3. So we have 3x plus 8, I believe. No, minus 8 times x plus 3. Since 3x times 3 is 9, minus 8 is 1. So we get that x must be equal to 8/3. So yeah, knowing that, we can calculate the other two angles. So if this is 8/3 and this is 16/3 minus 1, which is 13/3. Let's calculate the other two, and we only really need to calculate one. Let's do this one. So we have cosine B is equal to 5 squared plus 13/3 squared minus 8/3 squared all over 2 times 13/3 times 5. So this is equal to 25 plus 13/3 squared minus 8 over 3 squared, which is around 36.6, divided by 2, divided by 5, divided by 13 times 3. So I get 0.846 for this, and so the angle must therefore be equal to 32.2. Okay, and then now we can, I guess, cheat a little, since we know that angle is equal to 60, this angle is equal to 32.2, and the angle should add up to 180. The final angle is 180 minus 60 minus 32.2, and so this should be around 87.8 degrees. It's just maybe I made an error. 25 plus 13 divided by 3 squared minus 8 divided by 3 squared, all over 2, all over 13 over 3 divided by 5. Get 0.84, cosine negative 1 of that. I'm getting 32, so I'm not too sure where the book is coming from too much. Maybe the book's made an error. But that's all for the speedrun, and I hope to see you in the next one.